see the first one? Okay, according to this formula. Okay, so equal ln the modulus of minus 5 is 5. Okay, plus I, the principal argument of minus 5. Do you remember? Here is 0. Here is pi over 2. Here is pi. Here is minus pi over 2. So here is pi. So this is pi. Then plus 2k pi. This is the last answer. Is it not?
Yes.
Yes.
Yeah, I think here on this side we would have find this.
Yeah. Yes. Yes. Okay. The next one.
The next one.
Here is -3. Yeah. So ln the modulus of this is 5. Yes. Plus I, the principal argument of this. Okay. The principal argument of this is -3, 4. So the second complement. What happened? Yes, 5. Only 5. Yeah. Okay. Now I will compute this one. This one. Okay. Here is -3. Here is 4. So this angle is arctangent y above x. Okay? This is the principal argument of this. Plus, no, plus pi first. Then plus 2k pi. This part is the principal argument of this number. Yeah. Because it's the second, so it's arctangent y over x plus pi. Okay, the last one. This is the last one. Okay. Okay, equal ln the modulus of this is 4 plus 64. So it's 68. 68. You can also write this one. So here you can write this one plus I, the principal argument of here is 2, here is -8. So you can choose this one. Yeah, this one you can write arctangent y over x is -4 because it's belongs the fourth one. So only write arctangent y over x is okay. Then plus 2k pi.
What about pi?
No. Because it's the fourth. Okay, the fourth complement. The first one and the fourth one is arctangent y over x. The second one is arctangent y over x plus pi. This one is minus pi. This is true. Only arctangent y over x is okay. Understand it? Okay. But if you, okay, so in this part, if here is big, so equal this one plus 2k pi I, okay? But if you only write this part, not conclude this one, if you not conclude this one, we say omega equal small ln z. If here is small, only equal this part. This is okay. So we say this logarithmic factor is the principal. If there is no 2k pi I, we say this function is the principal logarithmic function. If there is a 2k pi I, we say this function is a logarithmic function. So there are many values, infinite values, but there is only one value of this function. There are many values of this function. There are only one value of this function. So because this is big L, this is big L, this is big L. So there are many values. There is 2k pi here. There is 2k pi here. There is 2k pi here. If I give you another question, for example, I only use to computer small l. There is small l 8i. If here is small l ln 8i, you only write ln the modulus of 8i is 8 plus I, the principal argument of 8i is pi above 2. Is okay. Not needed plus 2k pi because here is small. But if here is big, you must plus 2k pi. Understand? So if here is small, here is small. If here is big, here is big. Do you understand? So now please compute 2 by yourself. Compute 2. You must remember this formula. This is very important. And these 4 questions will appear on your test. The final test. So you must remember. So please compute 3. Okay? The first one is big. The second one is small. This is small. And this is also big. Okay? 3 questions. If you have understand these 3 questions, maybe the question on your test, you can also do it. Okay? Finish it. Yeah, right. Understand it? Next, let me see. The first one. First one, okay. This is ln the modulus of minus 5 plus 5. So this is, yeah. Okay, so the modulus is this. Plus I, because this is L, big L. So you need to write arctangent. This is minus 5 here. Arctangent. Minus 1. This is the second. So you need a plus pi. Then plus 2k pi. And arctangent negative 1. You can also write what? Pi negative pi about 4. Yeah. So this is yeah. Then 3 pi about 4 plus 2k pi.
You say that we are not write it down.
Because second here. Yeah, here, not here. So you better write like this one, okay? Yeah, like this one. Because this is small, so you only write long. This is 60, 36, 49. So here is 85. You are not 85. 85. Okay. 85. Plus I, you only obtain the basic argument of this. Okay. So it's minus 6, 7. So you can write arctangent. Y is 7, x is negative 6. But this is the second, so you need plus pi. Okay, it's okay, not 2k pi. Needed 2k pi because here is small. The second one. The third one, this is B. So here is long, this is 36. Okay? Okay? So here is 10. 10. So it's long 10. Plus I, here is B. So you need to write the principal is negative 6, negative 8. So it's the third continent. The third continent, the principal argument is arctangent. Y negative 8, negative 6. So here you can write 4 over 3. This is the third. So negative pi. Then plus 2k. Yes. If this requires to understand, very good. It's very good. Okay? All of this you have understand. So please erase the blackboard. power function. Okay. Okay. If omega equal Zn power, if n is integer constant, this is very easy. It's very easy. You can write z into exponential form. Okay? Then n power you can write r n power e I and z. This is very easy. But this n equal 0 and so on and so on. This is the first power function. Second one, if omega equals z alpha, and this alpha is this one, so you can write like this one. Okay, this one we have also studied. Okay, this one you can write R and okay E I. Here is n, here is theta plus 2k pi, and this k is 0, 1, 2. This is the second. Wait.伍志潮不回来吃，然后我们3个人回来吃，我跟伍思成还有 Snow。Okay, this is true. You have no. Yes or no? But now I will teach another one. Another one. If this alpha is not this n, and is also not this 1 over n, but this alpha is a complex number. Complex number. If this alpha is a complex number, how to compute this one? How to compute this one? Is also very easy. I think it is. Maybe it's difficult for you, but for me, I think it is easy. Okay, let me see. Okay, if this alpha is complex, if you want to compute this one, it's very easy. You can write this z alpha. You can write e ln z alpha. This is e, this is ln, so cancel. So omega equals z alpha. You can write e ln z alpha. And ln z alpha, you can write e alpha ln z. So if you can compute this one, you can also compute this one. Okay? So I think it's easy. For example, okay? If you want to compute, this is complex. This is also complex. If you want to compute this one, you must use this formula. Use this formula. Okay? You can write e ln. Okay, so you can write e I. Okay, understand that? So can you compute this one? Yes, you can. Just now you modulus of this. The modulus of this is this. Yeah. The principal argument of this is pi over 4. Then plus 2k pi. Yeah. So the last answer, you can write E. This is the first part. The second part, I square. I square is negative. Negative. Okay? So this is real. So this is real. This is real number. This is complex number. But this complex number, you can use the Euler formula. Euler formula, yes. You can write, yeah. This is the real number. This is cosine ln this one plus I sin ln this one. Okay. Continue. Finish. Finish. And this k can be 0. And so on. So there are many values for this number. For this number. Do you understand? Yeah. If you understand, please try one by yourself. Okay? Please try. If here is 1, here is this is the first question. The second question, if here is 3i, here is r. This is the second question. Please do this question. If you finish, this class is over. Second one is this. This one. This one the same, but this alpha is this. This alpha is complex or other numbers.
The question is only.
So you can say you can delete this one. Okay, you only write like this.